All right. My name is Danny Gierhart, Dannygierhart. I am a senior regional engineer with the Asphalt Institute.
How long have you been with Asphalt Institute?
I've been with the Institute now about 10 years, coming up in February, I think so.
What did you do before that?
I spent 20 years as the bituminous engineer at the Oklahoma Department of Transportation. I worked for 4 years as a materials engineer for Brose Construction Company, a contractor that worked in Oklahoma, Kansas mainly, but also Texas, Colorado, New Mexico a little bit. I spent 11 years as an adjunct instructor at University of Oklahoma, teaching asphalt materials and mixed designs.
So I say boomer.
Sooner, yes, you got it.
So thanks again, Danny, for agreeing to spend some time with us this afternoon. Try to make this as painless as possible.
Very good.
But as we're talking about these topics, the first one we'll talk about is density and durability.
Yes.
If you could talk to us about the relationship between density and improved durability and performance.
Yeah, and that's a very important question because one of the most important things for the longevity of a roadway is proper density in the field. And we have found through studies that if we get about 1% more density, we can add 10% more longevity in the field. So we can add a lot of years just by getting proper density in the field. So a very important relationship.
Now, what about the relationship between, let's see, I think I did get that question. What are some critical things that DOTs need to consider for ensuring optimal density?
Things for the DOTs to consider for optimal density. Well, there's so many things that interact in that. And so on the agency side, the agency writes the specifications for the materials. They write the specifications for the process of placement and compaction. So early specs were method specifications. The agency said, this is what you do, this is how you do it, and there was no room left for innovation by the contractor. And as we transition from method specifications to end result specifications, where the agency just says, this is what I want quality-wise, the contractor now has the ability to do more things to innovate rather than being restricted by the specifications. So there's that issue. Materials-wise, you have to have proper specifications that will result in a mixture that has those qualities where it can be compacted, and there are properly. There are mixtures that are, we say, harsh, difficult to compact in the field. There are mixtures that are tender, that tend to move around under a roller. And so the mix quality does have an effect on the final product. And so there's the mixture aspect, and then agencies tend to specify what types of rollers, how many passes sometimes, and so there's some good about that we have historical proof that if this has worked well in the past, it will work well now. But again, I think we need to give our contractors the ability to try new things to make our product better.
That's great. That's a great answer. You brought up some things that I've talked to a few folks already here and in other places, and you brought out a few things that no one else had.
Okay.
And so I appreciate that. Now, working with the Asphalt Institute, you say you represent suppliers mainly.
Yes.
Is there, with density and durability, is there a role that suppliers can play? And if so, what is that role?
Yes, there definitely is a role, because the suppliers, the liquid asphalt suppliers, they can make unmodified unmodified binders, which is good for most of the things that we need. A lot of general use. An unmodified binder works fine, works well. But then the suppliers can add polymers and even some other additives to increase maybe the stiffness at high temperatures. And so asphalt, as you heat it, it gets more liquid, right? But if you add a polymer to it, we can add stiffness even at higher temperatures to improve rut resistance. We can do things on the cold temperature side. So asphalt in cold weather, the pavement wants to contract and pull in on itself, and then at some point, if that asphalt binder is not flexible enough to withstand those contractive forces, then it can crack. And so we can put additives in that binder to make it where it's flexible at cold temperatures. And so the suppliers do have a large part to play in the ultimate performance of the asphalt mixture.
Very good. Here.
I don't, it's hearing now.
Okay, you're not hearing folks on stuff. If that keeps up, I might have to give them a stern photographer look. So, what are some ways, let me ask you this question. What are some ways to provide density quality assurance?
Density quality assurance. Well, the gold standard as far as quality assurance and roadway density and asphalt mixtures is coring the roadway and testing the cores to see what the air void content is. So the air void content and the density are brothers, so 5% air voids, 95% density. The cores have historically been the best choice to get the most accurate determination of what the true air void content is, or the density. We have nuclear density gauges available to us. We have non-nuclear density gauges. So they play an important part in that a nuclear density gauge, it does need to be calibrated with a roadway core to give me the proper density, but it's very good at telling me when the density goes up or when the density goes down. And so a contractor can use a nuclear density gauge or a non-nuclear density gauge during construction to let us know if we are still achieving compaction and if we're improving compaction. And so the number may not be known to the contractor at the time until it's correlated with the roadway core, but they're great tools for determining compaction.
That's good. Very good. What's temperature on that density?
Temperature has a huge effect on density, and I would say that is the most important role of the roadway inspector, is to ensure that the asphalt is delivered on the project at the proper density, that it is paved and compacted at the proper temperature. Typically we have temperatures anywhere from 325F to 350F at the plant to make sure that this mix is workable enough. But if we get too much higher than that, then we start losing some of the qualities of the binder and prematurely aging it. When it goes out to the roadway, most states have a specification that says it needs to be 250 degrees minimum, so preferably much higher than that. But as the asphalt is hot and workable, that's when you can get compaction. You can imagine once it cools down and becomes stiffer, it's very difficult to obtain further compaction.
So would you say, are there any changes to pavement design and asphalt mixture design that would make achieving consistent density easier for contractors?
Yes, I would say that. I mentioned before that there is such a thing as a harsh mix and a tender mix. There is a mix design methodology called the Bailey method that was introduced in the 50s by Robert Bailey of Illinois DOT. The Asphalt Institute has yearly classes about the Bailey method taught by Bill Pine now, and that Bailey method is able to help the designer make a mix that is optimum for compactability. And it can tell you, based on gradation and some other properties, whether or not this mix is tending towards the harsh side, tending towards the tender side, and helps you with tools to get it right into the proper gradation band to make it to optimize the compactability.
Good. So, Dave, talk about technology. How does technology improve or ensure proper density?
Okay, well, I think when we talk about technology, typically we think about field technology and asphalt rollers. So earlier rollers were, you hear the term steam roller, and so those were static type steel-wheeled rollers, and those do a good job. You need enough weight and enough passes to get over the pavement to get the proper density. In later years, they found out that they could make a vibratory motion in those asphalt rollers and impart some other forces to help compact the pavement to the proper density. And so now, in the early stages of compaction that we call the breakdown compaction, a lot of times we use those vibratory rollers to get the pavement very close to the final density that we want. And then the intermediate rollers and finish rollers finish the job. There are new compaction technologies. The vibratory roller now has different shapes of the vibration that it makes. Instead of an up and down amplitude vibration, now there is a kind of a back and forth design that a lot of contractors are finding a lot of success with. There are, never were before, rubber-tired vibratory rollers, but now there's vibratory rollers with rubber tires that can help with longitudinal joints. And so I think intelligent compaction is another thing that has come along in recent years, where we have GPS units on the rollers themselves to help track their location. They have accelerometers on the roller wheels themselves to determine the feedback as they run over the pavement to see how stiff it is. And so I think that intelligent compaction is also one of the big tools, new technologies that we have to improve compaction.
Very good, very good. So let's move to smoothness if we could.
Okay.
And I've got a lot of general questions, but I want to start first with a specific question for you.
Okay.
So I'm going to phrase it the same way that we talked about, talking about suppliers.
Uh-huh.
What would you say that a supplier's role is in achieving, down the road, achieving that proper smoothness?
I would say the suppliers in general have a lesser role than the paving contractor regarding smoothness. Now, the suppliers have an important role as far as material quality. Smoothness, I think, maybe the use of polymers where we have high traffic situations could help in some ways of smoothness. But in general, I would just say that suppliers have a minimal effect on smoothness. Liquid asphalt suppliers have a minimal effect on smoothness itself.
Okay. Yeah, fair enough. I want to give you a chance if there was something there
Yeah.
that I certainly wasn't aware of.
Yeah.
A chance to bring that out. So how does smoothness affect performance?
I spoke this morning about taxpayers, and we all have different jobs in the industry, and taxpayers really don't care so much about density, about the VMA, about what roller was used. What they want is a smooth, quiet road that lasts a long time. And so smoothness is very important to the taxpayers, the people who make our work possible. And so we need to put a lot of focus on smoothness because that's one of the aspects that the average person judges the quality of a roadway. And so I think smoothness is a very important part to our industry.
That's great. So talk about how smoothness is used or should be used in pavement design.
One of the considerations that we think about in asphalt construction in relation to smoothness, one of the nice things about asphalt is every lift that we put down increases the smoothness, typically around 50%. And so by designing a pavement with multiple lifts, that gives the contractor a better chance to make that pavement smoother and smoother and smoother with each lift. And so that's an important aspect of smoothness as far as pavement design goes. And also to realize that if we specify 2 inches of asphalt over a rough subgrade, you can get some help with the asphalt, but you're still going to have a rough road if you have a very thin lift over a rough subgrade or even a rough existing pavement. So there's some things design can do, but it can't do everything.
So, should the expectation for smoothness be independent of pavement material type?
If we are talking about different types of asphalt, I don't know that the type of asphalt influences the final smoothness that much. If we are talking about an asphalt roadway versus a PC concrete roadway, then I think the material selection plays a very big part in the smoothness. Traditionally, and a lot of reports would show that the asphalt roadways in general are smoother than the concrete roadways. And so if smoothness is important, and I think it should be, that is an important consideration when we're specifying asphalt.
What factors affect smoothness?
The factors that affect smoothness are what you place the asphalt on. So if the roadway is not smooth to begin with, the asphalt can help, but it can't help all the way. The way that we place it, when we pave an asphalt roadway, we would like that paver to begin in the morning and continue at a smooth, steady pace throughout the day without stopping and starting, and that's going to get us the smoothest road. Every time that the paver stops for any length of time, the screed tends to want to settle into the hot asphalt. The material under the paver gets cold, and then when we have a new load of asphalt come, that screed now has to climb up over that cold bunch of asphalt and then settles back down before it smooths out again. And so the ability to, as best we can, pave slowly and consistently throughout the day plays a very important part on smoothness. We also, the speed, as I mentioned, even if you can go without stopping, it's better to not slow down and speed up. That consistent speed keeps the right amount of material, a consistent amount of material under the screed, and that helps us to have a smoother pavement.
That's good. That's good. This may be. Let me ask you this: can you speak to smoothness specifications and how they're changing?
Yes, to some degree. Earlier smoothness specifications, the earliest smoothness specifications really involved just a straight edge, and we looked to see what the deviations from plane were on this long straight edge. Probably, and I'm not sure of the years, but a couple of decades ago at least, the California profilometer came out, and so that started being specified quite a bit more, where it was a kind of a rolling straight edge with a wheel in the middle of this long beam that would measure and document deviations from plane. And so that's been used for quite some time. It's very accurate. The con to the profilometer is that it's done at walking speed. And so the newest innovations are devices that can be run at highway speed, which I think is very desirable to get quick information, and also it matches what the driver feels. So the driver is driving at speed, so I think measuring it at speed and feeling those long swells, if there are any things like that, picking those up at highway speeds is a good thing, and we're starting to see that more and more.
So let me ask you this: you talked about technology on the density and durability. What technology is available to help ensure smoother roads?
There are different types of skis available that go on the sides of the paver, And what those skis do is help level out those deviations from plane. In other words, the plane is the smooth road. If we have a bump, we can use the ski to average out that bump over a long distance, and so that helps smoothness. And so for the contractor's point of view, that is very helpful. There are technologies that help monitor and alert the paver how much material is in front of the augers on the paver. So if I have too much material over the augers, the screed wants to rise up, and so that hurts smoothness. If we don't have enough material in front of the augers, then the screed tends to go down, and that hurts the smoothness. So there are physical and electronic means that will physically alert the paver operator when he or she needs to turn their attention to the material around the auger, and that's one of the more important areas for smoothness.
So, in our time remaining, just talk a few questions about long life pavements.
Okay.
And I'll start with this, specific to our suppliers, and I'll ask this question. What role would suppliers have in the whole process to deliver long life pavements?
Okay, typically when we talk about long life pavements, we're talking about a combination of stiffness of the material and thickness of the material to minimize the deflection at the bottom of the pavement as a heavy vehicle rolls over the top of it. And so like I say, we can, with regular materials, build it to a certain thickness to minimize that deflection at the bottom of the paver. We can, as suppliers, provide stiffer binders, more highly polymerized binders, and that would thin up the sections but still give us the same stiffness that we want to minimize those deflections at the bottom of the pavement structure. And so that's a very important role, I think, that the suppliers can work with the industry to help. At the NCAT test track, there has been some studies with what they call a high polymer binder, and so they have used a significantly thinner section and gotten similar results with a thicker section, but with regular binders or maybe just a regular polymer binder versus this high polymer material. And I notice as I go around the country, a lot of the state specifications now include a high polymer binder. It's not for every project, but there are certain times where that is a good solution to a problem.
That's good. So how, and you maybe touched a little bit on this just a second ago, but I'll ask this question. How do long life pavements, this is talking about fatigue and endurance limits.
Okay.
That define, let me ask you that and see if this is something that you want to answer. What are the fatigue endurance limits that define modern LL pavements?
Okay. When we're using term fatigues and endurance limits, we're talking about how much the bottom of that pavement can move before it begins to crack from the bottom up. So we can deal very well with cracks that start from the top down. We can just mill that top surface and repave very inexpensively, very quickly. When we get cracks from the bottom up, that becomes very problematic, and you're starting to look at reconstruction. And so we have seen those limits fluctuate. I think some of the earlier numbers were 70 microstrain, then 100, 125. That's what's been important about the NCAT test track, is they have had strain gauges placed inside the pavement with known loading, known material properties, known pavement thicknesses, and known strains, and that has helped them come to grips with a lot of these issues with a fatigue endurance limit. Because one of the other things that we think about is a limit. Well, the pavement stiffness changes throughout the year. When it's colder, it's stiffer. When it's in the summertime, it's a lot warmer. And so a pavement can withstand a much higher endurance limit in the summer months, for example, than it could at the winter months. So the main thing is that, or maybe I have that backwards, but we want to have that endurance limit such that we don't have bottom-up cracking.
That's very good. Let me, somebody's right outside this,
Okay.
We're probably 10 minutes or less.
Okay.
Let them know that. Hey guys, move on. Thanks guys. Danny, I apologize.
Not a problem.
We just, wheel that first about right here. All right. So the last question you answered was about fatigue endurance limits.
Yes.
And I think I want to just follow up. I really think I'm just going to do 2 more questions. And the follow-up question, though, to the fatigue endurance limits is how do fatigue endurance limits change depending upon types of materials?
Okay, well, the endurance limits themselves don't necessarily change. What changes with different types of the material is the thickness that provides that same limit. So as we mentioned earlier, a stiffer material, you can have a thinner section and still have the same stress or strain level at the bottom of the pavement. With a less stiff material, I would have to have a thicker section to have that same level of strain at the bottom of the pavement structure. So really it has to do with the stiffness versus the thickness.
Very good, very well done. And the last question is really going to be very open-ended in the sense that I'm just going to ask you, why asphalt?
Okay. Yeah, that's. I'm so glad that I kind of stumbled my way into to an asphalt career, starting with the Department of Transportation. When I was in school, I learned about steel, I learned about soils, I learned about PC concrete. I didn't learn anything about asphalt at the university. All of my training in asphalt came later in life, and a lot of that was on-the-job training. A lot of it was the manuals that are put out by the Asphalt Institute and kind of reading that and learning more about it. But as a practical sense, as my experience grew over time, I like working with something that I can believe in. And asphalt is the product of choice in my mind for roadways because it is smooth. That's what taxpayers want. It's quiet. And it's something that can be placed quickly. When you talk about being someone that's in the roadway or transportation industry, people tend to complain about construction and so forth. Well, construction times with asphalt are so much shorter than our concrete counterpart. That's really one of the nice, attractive things that I could maybe on a very busy section through an urban area come in at the middle of the night and mill off 2 inches and place 2 new inches of asphalt roadway. Commuters come the next morning, it's like a brand new road. It's smooth and it does its job. And so I think the appeal of asphalt to me is just the way it feels to a driver. I have even trained my kids when they were growing up. We do cross-country trips. Every once in a while, they would look up and say, we're back on asphalt, because they could kind of pay attention to their book or their game or whatever, just because it was quieter and smoother. And so those things draw me to asphalt. I think it's a great product with a lot of ways that it can be used, and I'm just happy to be part of the industry.